Welcome back to Pure Science Education, and today we're looking at manufacturing ammonia using nitrogen and hydrogen gas by the Haber process. You've been given a balance equation, which in the exam they can ask you to balance. They can ask you the symbol of reversible reaction, what it means to you. They can ask you for the conditions, but in this question they've been given to you, and they've asked you to explain these conditions and how you're going to use them in the process. Pay attention to the stuff in bold. So not only commenting on the yield, how much you're making, also the rate of reaction. So let's look at each one individually. So first of all, we're going to look at the pressure. Now, it's a 200 atmospheric pressure, which is quite high, which means if I've got high pressure, I'm going to get a high yield of ammonia. That means I'm going to make more of my product. Now, because it's high pressure, it comes with higher risk of explosion, which can be costly to store and maintain, because you've got to make sure we are safe when we're working with these kind of pressures. And finally, in terms of the rate of reaction, it's the second part of the question. If I've got higher atmospheric pressure, I'm also going to have higher rate of reaction. The second thing they asked was temperature, which is 450 degrees. So again, it's a higher temperature means a higher rate of reaction. It's going to have increased rate of reaction here. It is the optimum temperature for this experiment for the Haber process. It's the best temperature. If you look at too high temperatures or too low, then the catalyst doesn't work, or the reaction's too slow, or if you look at extreme temperatures, then it's too dangerous to work with and too expensive. Also, the forward reaction is exothermic here, so that means there'd be higher yield of ammonia again. However, if I look at lower temperatures, then it'll be the reverse, it'll be lower rates of reaction. And finally, looking at the iron catalyst. Now it will speed up the rate of reaction. If I look at lower temperature, it'll save me energy because I'm using the catalyst, increase the yield, and then the rate of reaction will be equal for both sides of reactant and products. This is a typical follow-up question for ammonia Haber process. They're giving you this time a graph of different temperatures, looking at the yield at the same time, and they're asking you why operating 200 atmosphere and 450 is ideal. So if you look at the effect of pressure, like we discussed in the previous slide, effect of pressure will be, if I increase the pressure, I increase the yield. However, increasing the pressure also increases the cost and the safety, as discussed. So and then in terms of temperature, so effect of temperature, if I lower the temperature, will then lower your yield, so it decreases the yield. And it's an exothermic reaction going forward as well, so we need to be careful on the temperatures. Now the compromise here will be the optimum conditions. So the reason why we are sticking with the 200 atmospheric and 450 will be that we are compromising. So in terms of compromise is the optimum conditions in terms of pressure and temperature. It balances the rate of reaction and the yield. And also the rate will slow down because we're going to need a catalyst. So it's going to help us get the conditions right because we're using a catalyst. So we're still going to get the correct yield, the lower temperature and pressures. I hope this helped. All the best. Thank you.